All right, so what you're going to look at now is the situation with simple machines of pulleys. You've calculated mechanical advantage by input distance divided by output distance, and output force divided by input force. Now we're going to look at how this relates to pulleys, okay? So on the pulley simulation, there's a couple things you want to look at. You want to look at the different types of pulley systems because you are going to be responsible for knowing what is the difference between a fixed pulley and a movable pulley, and you can just click on them and see how that changes the pulley system and what it means for single compound, double compound, triple, quadruple, so on and so on. And then you can build your own when you get to that, okay? So this is one thing that you're going to want to take notes on. What do the different pulley systems look like? The other thing, the load is set at 5 newtons. So that's the force that the load is putting out on us. So this is our output force, is 5 newtons. The distance to lift, I went ahead and cranked it to 0.2 meters. Nothing specific other than I just wanted to kind of give us time to see this happen. So I just moved it to 0.2. Your friction is going to stay at 0 and your pulley diameter is going to stay at 0.2 meters. We are not going to worry about this now. We're just calculating an ideal mechanical advantage. Your applied force is your input force. It's how much force are you going to have to use to move this object, to move this load. Now, down here, we're going to want to click the distance pulled, the distance moved. I'm going to actually remove the two works, and you want to calculate the ideal mechanical advantage. So this is your setup for your pulley simulation that you want, okay? So what we're going to do is you may notice that it already tells us the ideal mechanical advantage is 1. Well, that's odd. I haven't done anything yet, but there might be something that makes sense here pretty soon about why we know that before we even do anything. So I'm ready. I'm going to come up here and I'm going to grab the string and pull down. Shows me where the force is applied. We see the item moving, and we notice that the applied force, my input force, is 5, and my output force, the load, was 5. So 5 divided by 5 is 1. Ideal mechanical advantage of 1. Okay? Now remember, we also can do the input distance divided by output distance. So the distance pulled, the distance that I had to move it, was 0.2 meters, and the output distance, the distance that it moved, like how high we were trying to move it, was 0.2. Divide the two of those, and we still get a mechanical advantage of 1. So this is using both of those formulas that you just practiced on the other problems. Well, let's change it to single movable. Now notice when we changed it to single movable, the ideal mechanical advantage already changed to 2. So what I want you to do as you're doing this is look at the pulley system and see if there's anything that you can notice about the setup compared to what the mechanical advantage says. So I'll go back here to the single fix really quickly. Notice that we have one string. Okay, so even when I pull down on this, think about how many strings are actually working on the load. We have mechanical advantage 1. So I'm going to go to single movable. So everything else stays the same. So let's go ahead and pull this up. Now notice the force applied. How much force that I have to put in is half, 2.500 newtons. So output force 5 divided by input force 2.50 is 2. That told me that this pulley gives me a mechanical advantage of 2. Let's look at it the other way. The output distance and input distance and output distance. The input distance, I had to input a distance of being pulled of 0.4 meters. The output distance, the how far it was moved, was 0.2. Divide the two of those and you get a mechanical advantage of 2. Okay, so we should be seeing something here. Now, as we move through it, you want to take a look at what is the ideal mechanical advantage related to the setup. And I kind of pointed it out already when I said something about the strings. Okay, so what I need you to do is go through this simulation, record your data with the output force, input force, your input distance and your output distance, and how you got to the ideal mechanical advantage. We will deal with these in the lab. However, we will never go past the single compound because once you get down here, strings get tangled, they fall off, they break. It is a nightmare. So we don't build a bunch of these in the lab. We build a lot of the just simple beginning ones. Okay, so this is the best place that you're going to get your info about these pulleys. So work through this, gather your data, and tomorrow we'll be doing the lever lab and then working on this pulley system a little bit more.